Hello, it's time for a mechanics question, a pulley on an inclined plane. What more could you want? Hope that's why you tuned in, okay? I've got one here for you and it's a beauty. There's a lot of reading to do before you get to the actual question. Such is the way of some of these modern exams. But here we go. I'm just going to come out of shot in case you want to just take a photo of that, screenshot, okay? I suggest you read through the whole thing, maybe have a go at yourself and then come back later and watch my video just to see how you got on. Okay? Or just follow me going through this example for you. So this figure here shows a block of mass M held at rest on a rough plane. So that it's rough is important because that means friction will come into play somewhere. The plane is inclined at an angle alpha to the horizontal. Coefficient of friction is mu. One end of the light inextensible string is now attached to A. The string passes over a small, smooth pulley, which is here, which is fixed at the top of the plane. The other end of the string is attached to block B of mass Km. Block B hangs vertically below the pulley with the string taut. All right. String from A to the pulley lies along a line of greatest slope. So basically it means we don't have to consider the 3D aspect, is what I'm getting at there. Both A and B are modeled as particles. When the system's released from rest, A moves up the plane, so that way, and the tension in the string is 4 mg over 3. Given that mu is a third, tan alpha equals 7/24, find these. Magnitude of acceleration of A, give your answer in terms of g, so that's important, and find the value of k. Okay, so notice I've just underlined a couple of important bits there, so rough, so we're going to have to use F equals mu r at some point, and we need to give our answer in terms of g. Okay, so that's the question. This is basically the information we need to know. Okay, so here I'm just going to redraw the diagram. Okay, in an exam you probably just add to the diagram you're given, but I prefer to redraw these diagrams myself. So here's the inclined plane. There's alpha, and there's particle A. So the weight downwards like that. M times by g is the weight. I normally put in this weight triangle here because it's how I resolve both parallel and perpendicular to the plane. The plane keeps going that way, of course, because there's friction involved, there will be normal reaction, so that's that way. And then I do my smooth pulleys like this, and then there's the string, there's particle B, so it's labelled at A, labelled at B, and there'll be a weight on B, which is going to be K, M, G. There's tension. We're told it's that, but in my diagram, I'm just going to label it as tension like this. So T that way and T that way. A is moving this way, so I'll put acceleration that way. Because it's moving that way, the tension is that way as well, because it's pulling the thing up the slope. And then because it's on and attached to a pulley, B is going to go this way, downwards. Okay, it must do. The whole system must go that way. Okay, and what else have I missed? I think that's pretty much it, isn't it? Oh, the friction force as well, of course. Because it's moving that way, the rough slope, it's going to have friction, which is that way there. That's pretty much it. Okay. Given that mu is a third, so mu is F equals a third r, F equals mu r at some stage. Tan alpha is 7/4. I'm just going to put some rough work in here to work out sine alpha and cosine alpha. So alpha 7/24, opposite over adjacent, 7/24. So that's a 7/24 triangle. Of course you knew that. You might have used a calculator to work out 25, but it's a 7/24 triangle. That means sine alpha is equal to 7/25. That's opposite over hypotenuse. Let's put a right angle in there. And cosine alpha equals 24/25. That's adjacent over hypotenuse. I no longer need this. I'm just checking that I've recorded this correctly. Yeah, and ready to go. Ready to answer the question. Okay. Find the magnitude of acceleration of A. So we'd have to resolve both parallel and perpendicular. I'm going to do perpendicular first. I always do perpendicular first when you've got friction involved because it enables us to work out the normal reaction. And then once we've got normal reaction, we can work out what F is. So I normally do it in that order. Okay, so perpendicular to the slope. R is going to be equal to that bit there. So R and that bit there is going to be and the perpendicular bits. So that is cosine alpha. Okay, and because it's opposite, so in other words, this weight triangle is that way and then that way, R is going to be equal to mg cosine alpha. And I'm just going to put in there 24 over 25 for cosine alpha. 24 over 25 mg. So that's what R is. If you want, straight away you can work out F. So I'm just going to put therefore F is equal to 1/3 of that. Remember, there's a method mark for usually using that somewhere. So 1/3 of R, that's nice and handy, isn't it? 1/3 of 24 is a convenient number, so it's 8 over 25. Little things like that please me when you've got nice values that you can divide by 8 in 3 in this case. Then we're going to have to resolve parallel to the slope. So parallel to the slope, it's going that way, so up the slope is the positive direction. So T is going to be positive, and then the rest are going to be negative. Okay, so we've got to subtract the weight. So subtract mg, and that's going to be this bit here, which is opposite alpha, so sine alpha. So mg sine alpha. And also, we've got F is down the slope. So you've got T minus the weight minus the frictional force. And that's equal to mass times acceleration. Don't forget it's moving. It's moving up the planes, and you're going to have to find the acceleration, so obviously equals ma. So mass, which is m, times by acceleration. And I'm going to put the t and the f in there now. So t is that 4mg over 3. So 4mg over 3. Subtract sine alpha is that 7 over 25. So 7 over 25 mg. Subtract f, which I found is that 8 over 25 mg equals ma. And the lovely thing about that is all the m's will cancel. So you can just cancel all the m's if you want. So I'll just go out here. So m, divide everything by m. And you've already got, quite nicely, A as the subject, which is what you want to find. Okay. Just remember, we need to leave it in terms of g. Okay, so don't go put in a value of g into your calculator when you work it out. Keep it in terms of g. So what have we got? So we've got 4/3 g minus 7/25 g minus 8/25 g is equal to A. Okay. You can just work that out on your calculator. In fact, I'm going to do it now. Don't pause the video because I'm just a short step away, never too far away from my trusty calculator. Okay. Well, when I'm in my classroom anyway. When I'm at home, it's another matter. I've got to go looking for it. So I'm just going to type in 4/3. I'm not going to put g in my calculator. Just going to do the fractions. 4/3 subtract 7 over 25, and then subtract 8 over 25, 11/15. Okay. Just do not forget to put the g into it as well. Okay, so 11/15 g. Right. That's that bit done. Okay, it's in terms of g. Happy with that? Hope so. If not, just watch it again. Okay. Find the value of k. Well, here I've used my equations of motion for particle A. I've not done anything for B yet, and so to work out this bit, I'm going to use an equation of motion for particle B. Do you mind if I get rid of this? I'm sure you don't mind. Okay. Because I've got no more board space. Normally, I would go on to another of my board. Okay, you can't see it. I've got a board just over there that I would use, so that my class, which is here, will be able to see everything on the board. Okay, but because I am constrained by just one camera view, I've got to lob out and do it again. Okay. Anyway, so for particle B, I'm going to do it now. So it's moving downwards. Because it's moving downwards, we take downwards as positive. So the kmg is going to be positive, and then subtract t because it's in the opposite direction. So that's the total force resolved downwards, kmg minus t, and that's equal to mass times acceleration again. So don't forget the mass of B is km, right? So k m times acceleration. Now I'm going to put the t into it, which again was that. So kmg minus 4mg over 3. So that was t is equal to kma, and I've worked out the acceleration is 11/15 g. So that's going to be 11/15. Let's get the alphabetical order, shall we? So g K, M. I do like it when things are in alphabetical order. And we've got to work out K's. So nicely again, the M's will cancel. So M, 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 and the G's will cancel this time as well. Look at that. So G there, G there, G there. OG. So here we go. These days it's got another meaning, isn't it? Okay, so when I used to say OG, that means, oh wow. Whereas now, OG actually means something else, doesn't it? Yeah, original gangster or whatever. Original geezer, original guy, I don't know, original gal, whatever you want to, I don't know. What does OG actually stand for? I don't know. Okay, so that's the trouble with my age. I don't know these little things. I know there's OG, but I just don't really know what it stands for. Original something. Right, where was I? So I'm going to multiply everything by 15. So just helps to get rid of the fraction, you see. Or I'll just put the K put that onto that side. Yeah, let's do that. So 11/15 onto that side. So you have K subtract 11/15, so it would be 4/15. K on this side, and put this into that side, so 4/3. Yeah, it sounds about right, doesn't it? I can divide both sides by 4, so that's going to be just K over 15 equals 1/3, and then multiply by 15, K is equal to 5. That's it. That's that bit done. Right? Stand by because there's a part B coming up. Just got to resort my board for that. Okay, this is part B. Find the magnitude and resultant force exerted on the pulley by the string. Getting your answer in terms of M and G. So this is what I had before. What I didn't indicate before, because I don't need it, is because I didn't need for part A, that you've also got tensions there and there as well. Okay, remember there's equal and opposite tensions, right? Like a car towing trailer. Okay, when you've got a car towing trailer, you've got equal and opposite tensions. Just that when we considered particle A, you didn't need that bit. Same with particle. But when we're considering the force exerted on the pulley, that's what we're looking at, okay? And let me just draw that a little bit bigger so you can see what we're actually doing. Here's the pulley, and you've got tension that way, and you've got tension that way. Okay? That's essentially what we've got, and we're going to work out the magnitude of that. All right? What I'm going to do is I'm just going to redraw the diagram slightly. Sorry to get rid of this, I just do need the space, but this is the generic part of it, wasn't it? You had the alpha and then you had pulley there. That's the gist of it. Okay? I'm just going to redraw this. All right? So I've got tension that way. Okay, and then like with vectors, if you're going to set up a triangle of forces, it's a good idea just to draw one after the other. So you've got these acting on this object here, that way and that way, but when you draw them as vectors one after the other, you've got that tension and that tension. This is what we're trying to find there. The resultant, and we'll call that R. Okay, we're trying to find that resultant there, the magnitude of the result. So we're trying to find what R is. That's our goal. Now we know what T is because we worked it out, well, we were given it in the question, weren't we? We just got to work out what R is. We can use the cosine rule for that. Just need this angle here. And to do that, a little bit of angle work. So if we look here, because that is basically the inclined plane bit here, the inclined plane, you can say that that angle there is alpha because of alternate angles using power lines. That's a horizontal line, horizontal line. So that angle there is alpha. So that angle there is going to be alpha. That angle there is also alpha. That angle is 90. So all of that is 90 plus alpha. Does that make sense? I'm really hoping that does make sense to you. Okay. If not, just watch the video again. Okay. It's all about the power lines. I'm just going to get rid of that bit because it interferes with what I want to do in terms of my working. So that's 90 plus alpha. All right. Now I've worked out previously. You can see that there's a note to myself. Okay. We had this and this. You could work it out if you want using a calculator. Just do inverse cosine of that to work out alpha actually is, and then do 90 degrees plus that, do the cosine, you get negative 7 over 25. Anyway, that's cosine of that is negative 7 over 25. I'm going to use the cosine rule to do it. I'm going to get rid of this now because I no longer need it. Okay, so here we go. We're going to have r squared is equal to t squared plus t squared t squared plus t squared, subtract 2 times t, so that's times 2t squared, cosine 90 plus alpha. Okay, that's the equation that we want. I'm going to simplify it a little bit. So r squared equals, that's going to be 2t squared, subtract 2t squared, and I'll say cosine, what is that? Negative 7 over 25. So negative 7 over 25. So that's going to be 2t squared plus 7 over 25, so it'll be 14 over 25, multiplied by 2t squared. Yeah, I'm just going to factorise that. 2t squared, 1 plus 7 over 25, 32 over 25. Right, 32 over 25. All of this is r squared, don't forget. So r is going to be the square root of that. So before I square root it, why don't I just do 2 times 32 as well? Okay, so that's going to be 64 over 25 as the fraction, multiplied by t squared. Okay, so that's what r squared is. And then square root that. This is so lovely when it got nice square numbers they can easily reach. So root of that is 8 over 5 multiplied by t. I've just gone and forgotten what t is. Let's just have a look again. So t was, that 4mg over 3. Okay, so let's write it in here. 4mg over 3. So 8 fifths multiplied by that. So we'll put in 8 fifths multiplied by 4mg over 3. Leave your answer in terms of m and g, okay, which is nice and it's nice that you're expected to have mg in the answer, aren't you? Okay, so I'm just going to do 8 times 4 is 32, and 5 times 3 is 15. That won't simplify it as a fraction. So 32 over 15 mg. Okay, that's that. Okay, I'm hoping that made sense to you. I'm hoping the whole question was helpful to you in your preparation for your exams. Right, thank you for watching. See you again. Bye bye.